I want to prove this identity using mathematical induction. So first, the first natural number is when n is equal to 1. So when that happens, left hand side is x to the power 1 minus 1, which is 0. So x to the power 0, that's 1, and the right hand side becomes 1 minus 1 there, and then 1 minus x. So 1 minus 1 is that's 1 minus x there, x to the power 1 and 1 minus x, so that one is a 1. So basically left hand side is equal to right hand side for the first natural number, and then we go on to assume that when the relationship is true when n is equal to k. So let's do that, and the left hand side becomes when n is equal to k, it becomes when n is equal to 1, this is 1 plus x square. It goes on like that, because when r is basically when r is 2, this is 2 minus 1, that is x to the power 1. Then when it is 3 minus 1, that's 2, so on, so like that, and up to there when it will become x to the power k minus 1. So that is the left hand side when n is equal to k. And the right hand side, it will be, we are assuming that they will be equal, so that will be x minus k here, 1 minus x to the power k, sorry, and then 1 to the power x. So we are assuming that this one is equal to this one, and then we see, with that assumption, we see what happens when n is equal to k plus 1, whether we can prove the left hand side is equal to right hand side. If we can do that, we will have proved that it's equal for all n basically. So when n is equal to k plus 1, the left hand side becomes 1 plus x square plus x cube plus up to xk minus 1 plus x to the power k, like that. Now this one we have assumed 1 minus x to the power k, 1 minus x, because that's the assumption there. This part is equal to this part. So, and then here x to the power k, so we just do that, 1 minus x to the power k, and then we add this thing, the fractional addition, that's what we are doing here, plus that's actually a minus, sorry, so that will become a minus because this one is multiplied by that, so it's minus x to the power k times x. Now this one is going away, so it is 1 minus x to the power k plus 1, we can write, since x to the power k times x is x to the power k plus 1, and then the denominator is 1 minus x. So basically I will write it again, 1 minus x to the power k plus 1, and in the denominator 1 minus x. So this one is actually right hand side when n is equal to k plus 1. So this is the right hand side when n is equal to k plus 1, because this is the right hand side, and when n is k plus 1, this is what it is. So basically we have shown that when n is equal to k plus 1, the left hand side is equal to right hand side as well, if the left hand side is equal to right hand side when n is equal to k. So we have proved the identity using by the help of mathematical induction basically.